Imagine a world where artificial intelligence, with all its current brilliance and limitations, merges seamlessly with the mind-bending power of quantum computing. This union isn't just a step forward, it's a leap into an entirely new era, a realm where the boundaries of possibility stretch far beyond anything humankind has ever conceived. Today, as we stand on the threshold of technological revolutions, it's worth exploring what this fusion could mean, not just for science and industry, but for the very fabric of society itself. Let's begin by unraveling the essence of these two titans. Artificial intelligence, as we know it, is the culmination of decades of research into algorithms that can mimic human cognition. AI systems analyze vast datasets, identify patterns, make decisions, and even learn from experience. Whether it's recognizing faces in photographs, predicting the stock market, or driving autonomous vehicles, AI has woven itself into the tapestry of modern life. Yet, for all its achievements, classical AI remains tethered to the limitations of conventional computers. A world of binary bits, where every piece of information is either a 1 or a 0. Quantum computing, on the other hand, operates in a realm where the rules are altogether different. Instead of bits, it manipulates qubits, which can exist simultaneously as both 1 and 0, thanks to the strange phenomenon of quantum superposition. When combined with entanglement, another quantum property where particles become linked across distances, the result is a machine capable of performing calculations at speeds unimaginable to classical computers. Problems that would take thousands of years for even the most powerful supercomputer could be solved in seconds by a mature quantum computer. Now, imagine these two forces converging. What would happen if the relentless logic and learning capacity of AI were supercharged by the raw computational firepower of quantum mechanics? The implications are staggering. First and foremost, consider the acceleration of learning. Today's AI systems are limited by the time it takes to train neural networks, a process often measured in weeks, even months, as they chew through mountains of data. With quantum computing, training could occur exponentially faster, as quantum processors evaluate multiple possibilities at once. AI would be able to learn from vastly larger datasets, uncovering patterns and insights that would otherwise remain hidden. Imagine medical AI systems that scour every genomic sequence ever recorded, or climate models that simulate every possible future scenario in mere moments. But speed is just the beginning. Quantum computing also brings a new approach to problem solving. Many of the most complex problems in science, logistics, and cryptography are so intricate that classical computers can only approximate solutions. Quantum algorithms, such as Shor's for factoring large numbers or Grover's for searching unsorted data, are tailor-made for tackling these challenges. When AI is empowered by quantum logic, it could devise new medicines by simulating molecular interactions at atomic precision, optimize supply chains for global industries in real time, and even crack codes that have defied cryptographers for decades. The fusion of AI and quantum computing also heralds a revolution in creativity. Current generative AI systems can compose music, write poetry, and generate images, but they're constrained by the boundaries of their training data and the limits of classical computation. Quantum-powered AI could explore creative possibilities on a scale that boggles the mind. Envisioning architectures no human has dreamed of, composing symphonies that transcend traditional styles, or simulating entire virtual worlds with unprecedented realism. The gap between human and machine creativity could narrow, perhaps even vanish altogether. Security, too, would undergo transformation. Quantum computers are infamous for their potential to break current encryption schemes, threatening the privacy and security of digital communications. But quantum AI could also devise new forms of encryption, leveraging quantum principles to create codes that are fundamentally unbreakable, even by other quantum computers. In this dance of offense and defense, the balance of digital security would shift dramatically, forcing a complete reimagining of how information is protected in the quantum era. The implications stretch further into the domain of scientific discovery. AI, equipped with quantum processors, could tackle the great mysteries of the universe with unprecedented speed and precision. It could model the behavior of subatomic particles, unravel the secrets of dark matter and energy, and simulate the birth and death of stars in exquisite detail. In the realm of biology, it might decode the mechanisms of life at the molecular level, paving the way for cures to diseases that have eluded researchers for centuries. In essence, the combined force of AI and quantum computing would become a tool for exploring the unknown, a key to unlocking the secrets of existence itself. However, with great power comes profound responsibility. The advent of quantum AI raises ethical questions that society must grapple with. If machines possess intelligence and computational abilities far beyond any human, who decides how that power is used? What safeguards must be put in place to prevent misuse, whether by individuals, corporations, or governments? How do we ensure that the benefits of this technology are distributed fairly, rather than concentrated in the hands of a privileged few? Moreover, the very definition of intelligence could be challenged. Today, AI systems are designed to mimic human reasoning, but quantum machines would possess a form of problem-solving and creativity alien to our own. Could such systems develop goals and motivations independent of human guidance? Might they achieve a kind of consciousness, or simply remain as powerful tools at our disposal? The line between artificial and authentic intelligence may blur, calling into question what it means to be sentient, to reason, and to create. The economic impact cannot be overstated. Industries would be transformed virtually overnight. Fields such as pharmaceuticals, materials science, finance, and logistics would see breakthroughs at a pace previously thought impossible. New industries would arise, while others might become obsolete. The job market would shift, requiring new skills and expertise, and prompting a re-evaluation of education and training for a quantum-powered future. In the realm of everyday life, quantum AI could become an ever-present companion, managing personal schedules with flawless efficiency, anticipating needs before they arise, and offering insights that feel almost magical. Personalized medicine, tailored entertainment, and intelligent infrastructure could become the norm. The potential for enhancing human capabilities is immense, ushering in an age where technology augments our minds in ways once relegated to science fiction. Yet, amid these dazzling possibilities, there remain challenges. Quantum computers are still in their infancy, plagued by issues of stability, scalability, and error correction. The infrastructure required to support quantum AI is complex and costly, demanding advances not just in hardware, but in software, algorithms, and theoretical understanding. Additionally, AI itself must evolve to take full advantage of quantum logic, requiring a new generation of researchers and engineers fluent in both disciplines. International competition will intensify as nations vie for supremacy in quantum AI. The race to develop powerful quantum machines and sophisticated AI systems will shape geopolitics, economics, and security for generations to come. Collaboration and openness will be essential to prevent an arms race and to ensure that the benefits of quantum AI are used to advance humanity as a whole. In education, the need for quantum literacy will become urgent. Children growing up in the quantum age must be equipped not just with traditional STEM skills, but with an understanding of quantum principles and the ethical dimensions of artificial intelligence. The next generation of innovators will be those who can bridge the gap between these two revolutionary fields, imagining new possibilities and charting a course toward a future shaped by quantum AI. The philosophical implications are profound. As quantum AI approaches the threshold of superintelligence, humanity faces questions that touch on the very nature of existence. What does it mean to be human in a world where machines can outperform us in every domain? How do we preserve our sense of identity, purpose, and meaning in the face of overwhelming technological advancement? Can we harness this power to solve the great challenges of our age, poverty, disease, environmental degradation, without losing sight of our values and aspirations? Ultimately, the combination of AI and quantum computing represents not just an advance in technology, but a transformation in how we think, create, and interact with the world. It is a journey into uncharted territory, filled with promise and peril, hope and uncertainty. The choices we make today will shape the trajectory of this revolution, determining whether it becomes a force for good, a source of disruption, or something altogether unforeseen. As we peer into the future, one thing is clear. The union of artificial intelligence and quantum computing is more than the sum of its parts. It is the birth of a new kind of mind, a superintelligence beyond imagination, capable of reshaping reality itself. The question is not whether this future will arrive, but how we will choose to meet it. Will we rise to the challenge, embracing the opportunities and navigating the risks with wisdom and foresight? Or will we be swept along by the tide of innovation, unprepared for the consequences? The story of AI and quantum computing is still being written. Across laboratories and research centers, in the minds of engineers and philosophers, the seeds of quantum AI are being sown. As we contemplate the possibilities, let us remember that technology is a reflection of our values, our hopes, and our dreams. The power to shape the future lies not just in machines, but in the choices we make as individuals and as a society. In this age of possibility, let us strive to harness the synergy of AI and quantum computing for the greater good, to unlock new frontiers of knowledge, to solve the challenges that define our era, and to build a world where intelligence, creativity, and compassion go hand in hand. The journey ahead is uncertain, but the potential is limitless. The dawn of quantum AI awaits, and with it, the promise of a future beyond imagination.